I got 10 to the x is equal to 4. We're told to solve for x. 10 to the x is equal to 4. Maybe it'll all show up up there. 10 to the x is equal to 4. So what we know here is that the correct answer for x, it's got to be smaller than 1. Because if I plug the 1 in for x, 10 to the first is 10. Well, 4 is smaller than 10, so it's going to have to be smaller than 1. So it's some kind of fraction or a decimal. Your plan of attack for these types of problems are going to be most of the time to rewrite it in the form that it's not in. Your two choices for what form is it in are exponential or logarithmic. So looking at this, would you say this is an exponential form or logarithmic form? Exponential, very good. There's no log written there. It can't be log form if log's not written there. So that means we are in this form, and I want to take it to, I don't know, this form.
Does it do the full day?
Nope. Okay, so my base is the 10. So that's how we'll start here, log base 10. Now what's special about log base 10? Do I have to write the base 10?
No.
Nope. So I'm just going to write log. What's my n?
Four.
4 is equal to my e, which is x. So now this is just to pick up your calculator problem. You can hit math and go down to log base and fill in the base of 10 if you want to. But since it is base 10, then the log button over by the 7 would work just as well. So all you got to do right now is hit log 4. Let's round it to the nearest hundredth. What do you got to the nearest hundredth? .60. All right. Pretty easy conversion on that one. Okay. All right. Now this one says e to the 0.02x power is equal to 192. All right, that e, in this case, is the number e. We talked a little bit about it earlier in the week. Is that log or exponential form?
Log.
Do you see log written anywhere? So it's exponential form. So we want to rewrite it in log form. So I'm going to write log. What's the base?
190. Oh, the base? 192.
E of 192 is equal to 0.02x. Now Tuesday we talked about what log base e was the same as. Any clues or guesses what log base e was the same as?
1?
Nope.
10.
Nope. But it was that same lesson, Dustin, so you're
Natural
thinking,
log.
very good, Kaylee. It's the natural log. So the natural log of 192 is equal to 0.02x. So now all you're going to do, the natural log button is right below the log button on the far left. So you're going to hit ln 192, and then don't clear your calculator out. Keep that on there, because then x is being multiplied by 0.02, so you'll need to divide that by 0.02. Okay, so ln of 192, enter, divided by 0.02. What we got?
262.87.
Very good, very good. Good deal. Now, if you'd have hit natural log of 192 and rounded that and then divided by 0.02, in this class it wouldn't have been the end of the world. But when you're doing something where being more accurate and more precise is important, you want to try to round as few times as possible. That's why I was saying to solve it, save it, and don't round it yet. One of my favorite parts in the Hidden Figures movie is when they've trying to convert over to the computers there in NASA, but the computer's not getting the right trajectory or whatever it is that they're needing. So they get the lady working to do it, and she hurries it back over there and brings it in, and she carried her work out to more decimal places than the computer did. So she was more precise than the computers at NASA, which is pretty cool. But for this class, We're not launching a rocket into space with anybody's lives at stake or anything, so it's okay.
Just so, oh well.
Yeah. Too bad, Caitlin. All right. Moving right along. Maybe. There we go. Log base 3 of, switched gears on you, I hope you noticed, x plus 1 to the 5th is equal to 3. Alright, so the first two that we did started off in exponential form. This one is not, because it says log, so it has to be, silly guy, log form. So that means we're going to rewrite it into exponential form. Exponential form is b to the e equals n, so what's my b? 3 to the what power?
3.
Is equal to x plus 1 to the 5th. Good job. Now 3 to the 3rd, you can simplify that because you know what 3 times 3 times 3 is. So that gets you 27 is equal to x plus 1 to the 5th power. Now somebody in first period, when I asked them what we should do here, they wanted to figure out what x plus 1 to the 5th is. Holy cow. That means x plus 1 times x plus 1 times x plus 1 times x plus 1 times x plus 1. You have to write it 5 times and start multiplying all those together. No, I don't want to do that. What would be the easier way? How can I get rid of a 5th power?
5th root.
Very good. Bless you. I don't know what the 5th root of 27 is, so I'm just going to leave it as the 5th root of 27. Now I got one step left to get the x all by itself. Subtract that 1. And there's no correct place on where to put the minus 1. When a radical is involved, I always put it first, because if I don't, sometimes every now and then I get messy. I know y'all don't believe that. And you can't tell if it's supposed to be underneath my radical or not. So I always put it first so you're sure it's not underneath the radical. Mason, is that my marker?
I don't know, it's on the table.
Well, put the lid on it and quit wasting it. And that'll be all on that one. So we started off with exponential form. We rewrote them in log form. This one had log form. We rewrote it in exponential form. Now this next couple that we're going to look at have to do with some of the properties that we covered. We had 3 of them: product property, quotient property, and power property. So this is going to put those into play. I got a log base 8 of 2x plus 5 plus log base 8 of 3 is equal to log base 8 of 33. Now I told you earlier that your plan of attack was going to be to rewrite it in a different form. So you'd say, well, this is log form, I need to rewrite in exponential form, but this is a case where you can't because you have more than one log. So what we got to do there on the left side is condense that down to one log. So the first thing you should see blaring at you, and there's that addition sign. Which property did we learn about that was friends with addition? Very good, Kirsten, the product property. So we're going to multiply. So we're going to have log base 8 of 2x plus 5 times 3. And then we can go ahead and distribute that 3. That'll make log base 8 of 6x plus 15 is equal to log base 8 of 33. Now, what we got cracking here is similar to what we've had on the bell ringer the last couple of days. When you've got the same base equal to each other, you can just set the exponents equal to each other. When I've got the same logs equal to each other, then the other junk just has to equal each other. Log base 8, that's the same. So that means 6x plus 15 has to equal 33. So let's set that up and you got a 2-step middle school equation. First step there be subtract your 15. So I get a 6x equals 18. Is that right?
Yep.
Divide by 6. X is 3. I got one more of those. Got what we need on that one? Log base 3 of 2x minus log base 3 of 3x plus 15, so 15 with a funny hat on it, is equal to -2. Alright, so we're starting off with the same dilemma that we had on the previous problem. We've got two logs that we need to condense down to one. The sign that's separating those two logs is a subtraction sign. So which property did we have that was friends with subtraction? Division, very good. So this will be the same as log base 3 of 2x divided by 3x plus 15 is equal to -2. Now in the last problem, we just got to set the meat equal to each other, but we can't on this one because the log base 3 is not on both sides. So now we are going to rewrite this in exponential form. So b, what's my b? 3 to the
-2.
-2 is equal to that whole thing, 2x over 3x plus 15. Now 3 to the -2 is an easy one because you know 3 squared is 9, but since it's negative, that puts it on bottom and makes it positive, so that's the same as 1/9 on that side. Now there's lots of ways you can start solving that. This is one of my favorite things to solve when I have a fraction equal to a fraction. What's a good strategy that always works when a fraction is equal to a fraction? Very good, Chase. Cross multiply. So that 1 times that stays the same. So I'm just going to write 3x plus 15. And then 9 times 2x would be 18x. So I would subtract the 3x from both sides. Is that all right? So 15 is equal to 15x. So what does x have to equal?
1.
Oh, yeah. You got it, dude. All right, I got two different banking formulas that we got to use, and we're going to use them with some of the same information on a couple problems to see how they work out better for you or worse for you. But it's all about how the bank compounds the interest that you are in. This first one, and you need to label these always show up on your test. This first one is just a compounded interest formula. And it is A, final amount, is equal to P, that's the principal you deposit, times 1 plus the rate divided by N, and I'll talk to you about that, all to the NT power. Alright, so A is the final amount you're going to have in your bank. P is what you should put in to start with. It's always going to be 1 plus. That's constant there. It'll always be 1 plus. R is your interest rate. So like if it's 6%, you'd put a 0.06 there. N is the number of times that your interest is going to be compounded. Some banks will say compounded annually. That means once a year your N will be 1. Some would say semi-annually. Twice a year your N will be 2. Quarterly, 4 times a year your N will be 4. Monthly, 12 times a year, your N will be 12. So you got to read the problem and see what they mean on that. T, time in years, number of years you keep your money in the bank. All right, so here's what we got. Find the value of $2,000 deposited. So there's my P, my principal, $2,000. 5% interest, so my rate is 0.05. 5% interest compounded annually, once a year. My N is 1 for 10 years. T is 10. So this is a super duper easy problem to work because you're going to be able to use your calculator. You just got to make sure you get it all plugged in the right spots. So we got A is equal to 2,000 times 1 plus 0.05 divided by N to the NT power. Divided by N, it should have been divided by 1. I wrote an N down there still because I couldn't multitask. That's divided by 1. My N was 1. Alright, now when you're typing all that in your calculator, get some practice and make sure you can get it. this is the amount of money you have. So your money's rounded to 2 digits after the decimal, rounded to the nearest hundredths. So work on that and see if you can get a good answer for us. They got it? You got a 0.5 instead of 0.05. What do you think, Aaron?
3,257.7.
You did it exactly how much? Good. So what started as $2,000 ended up as $3,200 after 10 short years. That doesn't sound short to me. Now, going to use that same formula, but we're going to have to find something else, like a t or something that's stuck inside the problem when it's not as easy just to look for the a. So I'm going to write the formula again here for you. A equals p becomes 1 plus r divided by n to the nt power. This time it says find the number of years, so it is the t that we're solving for. Find the number of years it will take for $500 deposited, so there's your P, in an account paying 4% interest, 0.04, compounded semi-annually, that's twice a year, so your N's 2, to double. So that amount I deposited was $500, so to double, it would end up being $1,000. Be surprised how many people don't know what to put when it says it doubled. That's not very bright. Alright, so $1,000 is equal to 500 times 1 plus 0.04 divided by 2 to the 2t power. Now what I would do here if I were you, in case you see this on test next week, that 2t power is only on that parentheses. So I would simplify in that parentheses and get myself an answer first. I'd figure out what 0.04 divided by 2 would be, and then add that to 1. Ends up being 1.02. You can check me out. So I got 1,000 equals 500 times 1.02 all to the 2t power. Now we're trying to solve t. That 2t is only, like I said, on the 1.02, so I need to get rid, of the 500. What would my strategy be to get rid of the 500? Good, it's being multiplied, so we're going to divide it. So 1,000 divided by 500 is 2. Would equal 1.02 to the 2t power. Now, same as before, this is an exponential form, so we're going to rewrite it in log form. So we're going to have log base 1.02 of 2 is equal to 2t. So you're going to compute this in log base in your calculator. Whatever you get, you're going to divide it by 2. Tell me about how many years it would take. Years, we can work pretty good in years with partial years, so you can go ahead and give me a couple decimals or 1 or 2 if you want. What you got there, Caleb? 17.5 years just about. So for that money to double, it's going to take longer than some of y'all are old. That was years. Alright, and we got one more formula, and this one will specifically say continuously. It was compounded continuously. This is called the continuous compounded. This one's easy for me to remember because it kind of spells pert, and my granny always used pert shampoo. P times the number E to the RT power. The P, all the stuff is the same, except that E is the number E. So we'll have to practice pushing that button again on our calculator. A is your final amount, P is how much you deposit, R is your interest rate, and T is your time in years. So we're going to go back like we started with that first problem where we had $2,000 and 10 years and all that. We're going to use those same numbers and see which one of these would make us more money. So suppose that $2,000 is invested, so there's our P. It was 5%, so my rate's 0.05, and my time was 10 years. How much money will we have? So we're going to say amount is equal to 2,000 times the number E to the RT power. Alright, are you ready to start pushing some buttons so I can help you make sure you find the E? 2,000, type that in, get the 2,000 typed in. E is second LN. So 2,000 second LN, and then just fill in the 0.05 and the 10 up there in the exponent. What did I get?
3,297.44.
Okay, so that bank, when they compounded it continuously, got us almost $3,300. On that other problem, when it was compounded annually, it got us $3,257. So this bank made $40 more for us. Over 10 years, it only made $40 more. Spread that out over 10 years, not much, but it's $40 more. Why not? All right, what you think about that? Can handle all that? Just kind of puts it all together and all kinds of stuff. Gonna get study guide tomorrow. Go over some of it on Monday and take a test on Tuesday. That all right? Say what, Wilson?
Yay!
Yahoo! That'll be a wrap.
Penny a day.
Do what?
Penny a day.
Penny a day.
That's a little over.
What do you mean? How's that?
10 years. That's 300.
Oh, okay. The final amount. I got you. You divided that by a penny. Yes. I got you. I'm sorry. I wasn't focusing on what you were saying.